So, hey everybody, today we are going to see polynomials 2.4. So, let's begin. Without any further ado, polynomials like 5x to the power 4 plus 2x cube plus 7x square plus 10x minus 8 can be represented using arrays. Arithmetic operations like addition and multiplication of polynomials are common, and most often we need to write a program to implement these options. The simplest way to represent a polynomial of degree n is to store the coefficient of n plus 1 terms of the polynomial in an array. To achieve this, each element of the array should consist of two values, namely coefficient and exponent, while maintaining the polynomial. It is assumed that the exponent of each successive term is less than that of the previous term. Once we build an array to represent a polynomial, we can use such an array to perform common polynomial options like addition and multiplication. Program 1.2 accepts two polynomials as input and adds them. So here you can see program 1.2. The program accepts two polynomials as input and prints the resultant polynomial due to the addition of input polynomials. So here you can see the program, and yeah, you can see the output also. Then here the program initially prompted for the number of terms of the two polynomials. Then it prompted for the entry of the terms of the two polynomials one after another. Initially, it adds the coefficients of the corresponding terms of both the polynomials whose exponents are the same. Then it prints the terms of the first polynomial who does not have corresponding terms in the second polynomial with the same exponent. Finally, it prints the terms of the second polynomial who does not have corresponding terms in the first polynomial. So after that, it's representation of arrays 2.5. It is not uncommon to find a large number of programs which process the elements of an array in sequence. But does it mean that the elements of an array are also stored in sequence in memory? The answer depends on the operating system under which the program is running. However, the elements of an array are stored in sequence to the extent possible. If they are being stored in sequence, then how are they sequenced? It is it that the elements are stored row wise or column wise? Again, it depends on the operating system. The former is called row major order and the latter is called column major order. Row major representation. The first method of representing a two-dimensional array in memory is the row major representation. Under this representation, the first row of the array occupies the first set of the memory location reserved for the array. The second row occupies the next set, and so forth. The schematic of row major representation of an array is shown in figure 2.6. Let us consider the following two-dimensional array. So let's see. To make its equivalent row major representation, we perform the following process. Move the elements of the second row starting from the first element to the memory location adjacent to the last element of the first row. When this step is applied to all the rows except for the first row, you have a single row of elements. This is the row major representation. By application of above mentioned process, we get A B C D E F G H I J K L. So here you can see the figure 2.6 schematic of a row major representation of an array. Column major representation. The second method of representing a two-dimensional array in memory is the column major representation. Under this representation, the first column of the array occupies the first set of the memory locations reserved for the array. The second column occupies the next set, and so forth. The schematic of a column major representation is shown in figure 2.7. Consider the following two-dimensional array A C I B F G C G K D H L. To make its equivalent column major representation, we perform the following process. Transpose the element of the array, then the representation will be same as that of the row major representation. By application of above mentioned process, we get AEI BFG CG KDHI. So here you can see 2.7 schematic of a column major representation of an array. We'll check your progress too. And after that we have applications. So here only it ends. Let's see the applications part. 2.6 arrays are simple but reliable to use in more situations than you can count. Arrays are used in those problems when the number of items is to be solved is fixed. They are easy to traverse, search, and sort. It is very easy to manipulate an array rather than other subsequent data structures. Arrays are used in those situations wherein the size of array can be established beforehand. Also, they are used in situations where the insertions and deletions are minimal or not present. Insertion and deletion operations will lead to wastage of memory or will increase the time complexity of the program due to the reshuffling of elements. Summary. In this unit, we discuss the data structure arrays from the application point of view and representation point of view. Two applications, namely representation of a sparse matrix in a three-tuple form and addition of two polynomials, are given in the form of programs. The format for declaration and utility of both single and two-dimensional arrays are covered. Finally, the most important issue of representation was discussed as part of it. Row major and column major orders are discussed. So here we come to the end of this whole unit, and thank you. Till then, keep exploring.